Your body's ability to repair and regenerate tissues depends fundamentally on stem cells, those undifferentiated cells that can become specialized cell types and replenish damaged tissues. As you age, stem cell populations decline in number and function across multiple tissue types. This is stem cell exhaustion, and it's a primary reason why healing slows and tissue function degrades with age. The mechanisms behind stem cell decline are multifactorial and honestly quite concerning. Chronic inflammation damages stem cell niches, the microenvironments where stem cells reside. Oxidative stress causes DNA damage in stem cells, impairing their function or forcing them into senescence. Repeated cell divisions lead to telomere shortening in stem cells, eventually limiting their replicative capacity. Poor nutrition deprives stem cells of cofactors needed for maintenance and function. Different tissues have different stem cell populations with different sensitivities to aging. Hematopoietic stem cells in bone marrow that produce blood cells decline with age, contributing to immune system aging. Muscle satellite cells that repair muscle tissue become fewer and less responsive, contributing to sarcopenia. Neural stem cells in certain brain regions decline, potentially affecting cognitive function and mood. Nutrition plays a more significant role in stem cell health than most people realize. Vitamin D is crucial for stem cell function across multiple tissue types. Deficiency impairs stem cell differentiation and function. Most adults are insufficient in vitamin D, particularly at northern latitudes. Vitamin K2 works synergistically with vitamin D and has independent effects on stem cell niches, particularly in bone. Omega-3 fatty acids support stem cell membrane function and reduce inflammation in stem cell niches. Remember, chronic inflammation is one of the primary factors depleting stem cells. By reducing inflammatory burden, you're protecting stem cell populations. Fasting creates fascinating effects on stem cells that seem almost paradoxical. During fasting, stem cell populations actually contract as your body conserves resources. But upon refeeding, there's a robust regenerative response where stem cells proliferate. Prolonged fasting of 2 to 5 days appears to trigger significant stem cell regeneration, particularly in hematopoietic stem cells. This is one mechanism by which fasting may promote regeneration. Exercise mobilizes stem cells from niches into circulation where they can travel to sites needing repair. Moderate exercise appears optimal. Excessive exercise might actually deplete stem cell reserves through constant demand for repair. The type of exercise matters too. Resistance training signals need for muscle repair, mobilizing muscle satellite cells. Aerobic exercise affects different stem cell populations. Sleep is when much stem cell activity occurs. Growth hormone pulses during deep sleep support stem cell function and tissue repair. Chronic sleep deprivation impairs stem cell proliferation and differentiation. The research on this is clear. If you're not sleeping adequately, you're hampering your regenerative capacity at the stem cell level. Here's what you need to avoid, and this matters enormously. Excessive alcohol consumption damages stem cells directly. Heavy drinking depletes stem cell populations, particularly hematopoietic stem cells. Processed foods high in advanced glycation end products and inflammatory oils create an inflammatory environment hostile to stem cells. Chronic stress through cortisol elevation impairs stem cell function. Emerging research on stem cell supportive compounds is intriguing but requires caution. Yamanaka factors can reprogram cells to pluripotent states, essentially making them younger. This is extremely cutting-edge research, not yet applicable as an intervention. Follistatin, a protein that blocks myostatin, shows promise for muscle regeneration. Some athletes and biohackers are experimenting with these, but safety data is limited. The practical protocol focuses on creating an environment that preserves existing stem cells and supports their function. Adequate vitamin D and K2, omega-3 fatty acids, periodic prolonged fasting if medically appropriate, regular moderate exercise, consistent quality sleep, and avoiding stem cell toxins like excessive alcohol and inflammatory foods. You're not introducing new stem cells. You're optimizing the stem cells you have.